Hey guys, this is Mitch with FinePoint CGI, and today we're going to build a dynamic sound system. So we're going to go through the process of kind of planning out our sound system, and then we're going to create an audio manager, and we're going to create different surfaces. And the idea behind the system is each surface kind of houses a sound and values that are associated with that sound. So you can basically say, if I'm on this surface and I'm walking, I'm going to play this sound and it's going to put out this much volume. And then we're also going to build out a detection system with our enemy that falls off over distance. So that way our enemy, if he's far away, doesn't hear the sound as much as if he's up close. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so the first thing we have to do is we have to plan out our audio system. Now, we are going to need to refactor our entire player controller, and that's going to be probably our next tutorial, but in this specific one, we're going to talk a little bit about the project architecture as a whole, and we are going to talk about our audio system architecture. So for our audio system, we're going to have an audio manager. Okay. And that audio manager is going to house all of our sound effects that our project has. So, for instance, if a player walks on an object, then we are going to raycast to the object. We're going to get back some metadata that is on the object. And that metadata is going to contain some information, okay? And we'll actually pull out a thing here real quick and make this character. And we'll throw this up at the top like that. And we're going to make this a red color. There we go. Got to make it look pretty. And we'll get our object metadata from this raycast. And when we raycast our stuff, we're going to have inside that object metadata, we're going to have one metadata, which is the object type. And I can get rid of these too because I don't need them. So the object metadata is going to pull out the object type, okay? And what we'll do is we will pass that object metadata to our audio manager. So I'll draw a line like this. We'll just kind of do that. And our audio manager is going to have a dictionary, and it's going to house all of our sounds that are on that object. So it's going to read object sound index, and it will pull back the sounds that this object has. So we'll come down here and we'll say get object sounds, and it will return those sounds back like that. And then it will play footstep sound. And that's basically how we're going to handle our stuff. Another big function that our audio manager is going to have is it's going to have a dictionary of sounds. So, and this sound dictionary is going to have each surface's sound, which means that since it's going to have a dictionary of sounds, we also need to have a surface. So let's drag this out. So I'll make this green and we'll just call this a surface. And this is a sound dictionary, so it's going to have a surface name and a surface object like that. Let's get rid of these. And a surface is an object that just houses information. So it's going to house some small stuff. So it's going to house things like the volume of noise when you walk on it. It's going to house the jump land sound. It's going to house the walk sound. It will house the sneak sound if we have different sneak sounds. But we might need to record some Foley for that. So look forward for a tutorial where we actually talk about how to record Foley and how to actually create our own sound effects. Hopefully we'll be able to do that one soon. I will probably need to talk about how to get a hold of some kind of audio tool for this, or maybe I could use my smartphone, but we'll see. So look forward to that one. Now, with this is what this is going to house, is this data here. and it's going to get our object sounds. It's going to play the footstep sound, or in this case, the walking sound. And then it's going to broadcast audio level. And then we're going to have an enemy guy. So we'll drag this guy out here. And if you remember our enemy code, which if I go and fetch that real quick, so let's open this. We open this up in a new window here. You can see here's our enemy code here. With our close hearing, what we have is we have our close hearing and our far hearing, of course, right? Which automatically sets our states. But when we're doing our patrol, we should definitely make this patrol state a lot more complicated. So you remember how we have our light system, right? So when we're doing our patrol, we're setting our velocity, we're looking for if we're at our point, and then we continue, right? Well, we also have a lot more to look for. We want to check if we move towards our point and we are at our point, and then let's kind of grab these guys and pull them down like this. We're going to check for the player. So we'll drag this guy in here and we'll check for player light level. And then we're also going to check for player sound level. And that will basically allow us to have our states kind of be a little bit better, a little bit more intelligent, if that makes sense. And this is going to kill me if I don't adjust these to at least somewhat match up. So let me kind of drag these guys around. There we go. Now, basically, that's going to allow us to have a little bit of a more realistic system. And we're going to be checking for a sound level, which is going to be broadcast by our character here. Okay. And that's basically how I think we're going to handle it. Now, this audio manager will probably be a public static object in the world. So we'll go over how to do that inside of Godot. And we have our surface object. So that should work, I think. So now that we have this kind of planned out, let's go ahead and build this thing. Okay, so the first thing we have to do is we need to create our surfaces, okay? When the player walks over a surface, it's going to be playing a sound of some kind, and we need to set up some kind of pads for that. And what I mean by that is we, since this is a test bench, we need to actually build out something to test on. So let's head over to our node 3D. Let's right click, add a child node, and let's add in a CSG box 3D, just like this. We're going to drag this guy down, something like that. We're going to make him just a little bit bigger so we have something to play with. And I believe our player is right here. So let's just drag this over here and let's control duplicate it and drag it over here. Now we're going to call this one wood and we're going to call this one concrete. Now, these are just temporary test objects, okay? So they don't have any bearing on, the future or anything like that. This is a test scene for a reason. This is just for us to mess around with. Now, both of these guys are surfaces, but I didn't want to create a script to be attached to them because that would mean every object in the entirety of our game would need a script that describes our surface, and that was a huge problem. Now, of course, yes, I know that you can override and extend the Godot nodes, and you could probably make some form of way to make things sound different because of that, but I didn't really want to go that route. So what we'll do is we'll build a script called a surface script. So let's right click our scripts and let's add in a new script, okay? And we will call it a surface.gd. And our template will just be a regular node. That's fine. We'll hit create, and then we'll open her up. Now, first, we need to make a class. And in Godot, classes are kind of things, if that makes sense. Unlike C#, where a lot of times when you build stuff, since it's a big type-safe language, you have to make sure all of your stuff is like contained in classes. You don't necessarily need to do that, but since I do come from a C# background, I prefer doing it this way. So we'll type class underscore name surface, and we'll house a couple of vars in here. So first, we will say var sound value, and we'll export that out as an int, or we'll make that as an int. And then we'll say var walk stream wave : and we'll make that an audio stream. And then we'll just copy that 2 times for right now. We might need to make more, but I guess according to our plans, I think we had what? Walk, sprint. We had volume, jump, land, walk, and sneak. So walk, jump, land, and sneak. Now we'll probably not get to sneak, but we'll get, we'll see. And then we'll get rid of this guy because we don't really need any of this. That's just a waste of our code. Now our sound value is going to be used for our sound, how much sound is produced when we're on this. And honestly, we might want to copy this and say sound land value as well. When a character jumps and lands, they're going to produce a lot more noise than if they're walking. So we might want to have a sound land value as well. Now, next, we're going to build ourselves an audio manager, okay? And an audio manager is super useful if you want to basically keep track of all of the audio that your game has. Now, there are 2 schools of thoughts. One is, hey, I'm not going to worry about building an audio manager, and I'm not going to house all of my data inside of one manager. Instead, I'd rather break it out among all of the rest of the things. So, for instance, like an enemy or a door might house its own information. And there are some truth advantages to that, but I'm going to instead just have an audio manager that just houses everything, at least when it comes to, walking, jumping, sprinting, crouching, things like that, because it's going to provide us a lot of flexibility. So what we'll do is we'll right click our scripts. We will add in a new script, and let's just call it audio manager.gd. And let's open her up just like that. And I'm going to name this a class underscore name audio manager, and we'll make that extended node. I think that'll be fine. And we'll come down here, and we need to basically load our audio information, okay? And the easiest way to do that, since we don't actually have the ability to export out that data, we need to hook it up in code. Now, there are ways around it. You could do some cheating, and the way that I'd like to do this is I'd like to have it all out in a text file that I can edit later, and we'll get to that when we do our saving and loading system coming soon. But for this specific case, I'm just going to load it in my ready because I'm lazy and I don't really want to build out something crazy. So we'll just put var s for surface. We'll make that a type surface. And you'll see, weirdly enough, now we can actually make this as a type surface, which is our script right here. And that's because we have that class name. So that was one of the reasons why I wanted to put a class name up here, was because we can actually pull that information right here. And now if I hit S dot, you will see that all of those variables that I had, they're right here. We can actually use them, which is really cool. So just, so that's the reason why I wanted to use a class name, was so that I can access it and have type safety, if that makes sense, or at least have auto completion. So what we'll do is we'll set our walk stream wave, and we'll make that equal to resource loader.load, and we got to load something. Now, we don't actually have any audio to load, but we can get some really, really easily. Now, on my GitHub link in the description, I have all of the audio files. Just pull down the latest project and then just extract them out of there. Or if I'm feeling lucky, I'll put them out on my Google Drive, and you guys can pull those down as well. And they're all from a website called freesound.org. And freesound.org is an awesome audio library that is all free, and it's all usable for you for your games. Now, you do have to pay attention a little bit to the licensing. So you can see how this little guy has like a 0. That means it's perfect for games. 0 is great, 0 is great. But you'll see this one here has a license, and it says that it is sourced under the Creative Commons Attribution license. So what that means is that you cannot use this without crediting the author. So you have to say, this river summer was created by this guy, by, Clank BLD, I think is how you say his name. And you just got to make sure that you put them in your credits and say that it was done by, this guy. And if you ever see this symbol, then this means that you have to attribute this guy, Philip Goddard, and you cannot use it for commercial purposes. So that means you can't really use it in your game if you're going to make money off of your game. So that's something to keep in mind. Now, if I turn on my desktop audio, and let me turn this guy up here so hopefully you can hear this, I can show you kind of the really useful sound effects you can get. So if we type walk, you can see they have all sorts of, I guess, maybe walking. There we go. You can see that there are all sorts of sounds here. So if I click, you can see there are a lot of sound effects. Now, you have to be cautious because a lot of times you're going to need to do a lot of audio processing on these sound effects. That's the reason why I went through and did my own edits to the sound effects. So if I head over to my actual test bench here, you can see I have a couple of them. So like the Martin footsteps, the hit mount walk, a jump land, things like that. I had to edit these to make them, able to be used for our purposes. So what I will do is I will leave these in the link in the description for you guys to be able to download, but I'm going to pull these guys because I already have them done, and I'll just pull these 3. Let me see. Yeah, that's not one that I was looking for. I think it's just these 3. So I'll pull these 3 in like so, and I will bring them into Godot real quick. So let me click on Godot. Let me drag these guys in. And we're going to need to make some adjustments to our original design here. We're going to need an audio effects section. So let's right click, new folder, and call it sounds. And let's drag these guys down here. And of course, if you guys want to rename these, you guys can. So like, for instance, I will probably already have these renamed. But you can see like this is really complicated. So we'll just call it footsteps on wood. And I believe this one is landing on wood. Jump land. And then this one is walking on concrete. So we'll say footsteps on concrete. And then in our resource, when we want to load that data, we can just come in here and find our footsteps on wood.wave. And then we can do the same thing for our next thing. So s.jump land is equal to, let's grab this resource loader.load, and let's pull up our jump land sound. And then s.audio, I believe it was sound value, is equal to something like 5. I don't know yet. We're going to need to mess with that. And then s.land sound land value is equal to 10, let's say. And granted, I don't know what this is going to be, but we'll get there when we get there. Now we're going to need a dictionary to house this data. So let's come up here and say var sound dict and make that a type dictionary. And we will add our surface to that. So sound dict, and we will name it wood is equal to S. And that will add that surface to it. Now, basically, we could just copy this guy and we can just paste it like this, and we'll probably want to build some kind of function for this, but we'll get there when we get there. So we'll say var concrete, and let's basically just replace these guys like so. And I'll probably want a capital C, so that way it kind of keeps up with the architecture we have. And then we can come over here and we could change this from footsteps on wood to footsteps on concrete. So let's just grab this guy rename, copy it, and let's paste that. And we'll keep the jump land, that's fine. The sound value, since concrete is probably going to be louder than wood, the sound will probably carry farther. We'll make that a 6, make that a 12. And there we go. So now we're going to have a dictionary that houses this sound and this sound library, if that makes sense. And now we can set up our player to actually use these values. So now that we have our audio manager done, let's build out our player stuff. Okay, so we'll head over to player and we'll go into our character, and under our physics process node, we're going to need to basically link up all of the work we've done. So we have our audio manager just sitting out in space, and we have our object here, but we need a way to link them. Okay. And how we're going to do it is we're going to figure out, we're going to raycast and get back our object. And then we're going to pull back some data on the object, and then we'll determine what type of object it is, and then pull back the surface from there. So first we have to do our raycast. And what we'll do is, much like before, if you remember in our enemy section here, we did a raycast right here. So we'll just basically just copy this guy, bring it over here and paste it, because that's going to save us a lot of time. And instead of naming this as result, let's name it surface result. And name this surface result as well. And we'll come over here and we'll just put in, instead of head.global position, we'll just pass in our global position. And we'll make that plus a vector 3, 0, 1, 0. And then we'll do our global position again, basically this exact same thing. So we'll just grab this guy, paste it like that, and we'll just do -1. So what this is going to do is, if we go to our player scene here, like so, you can see here's our player, and we're basically raycasting from here down to about here-ish, somewhere in this area. We're literally raycasting one full block unit, well, technically 2 block units from the player. So we're raycasting basically from here to like here. So that way, pretty much anything that's underneath the player will know it's there. Unless the player is falling from a really, really great height, we are going to be able to know what the player is standing on. So let's head back to our script and let's come down here. We'll say if our surface result is greater than 0, and we're going to want to check if our surface result has a collider. Since this is below the player, we can't guarantee that there's going to be a collider there necessarily. So we want to make sure that the result has something, because sometimes if the player's in the air, that raycast might not hit something, and that could cause a lot of problems. So we'll just say if result dot has quote collider, then we can go ahead and load our object. Now, when we go out and fetch our object, we need to cast it as a type. And the reason why is because we're not going to get auto completion, and I like to have auto completion. So I'm going to do that real quick. You don't have to do that, but I'm going to. So var surface object, and we'll make that a type node 3D like that. And we're going to make that equal to a result, and we'll hit quote collider, and then we can pull back our sound. Now we have 2 problems. One, we already have a variable named space state, so we can fix that. So we can just come down here and find our space state right here, and we can just kill that because we already have a space state. We don't need multiple space states. I think that will work. And our second one is we need to be able to get back our audio library, and we need to determine if our surface is a different type. So let's solve this one first, and then we'll do our audio library. So how can we determine if an object is a different type of object? Especially since if we look at our test scene, there's really nothing unique about our two objects. We could create a script, which would require us to have a script attached to everything, which is a valid use case, right? We could do that. Or we could pull back maybe a meta object. It's really up to you guys on which one you guys want to do. In my case, for right now, and it's probably going to change as time goes on, but what I'm going to do is I'm going to add metadata to the object. I think that's going to make it a little bit easier and a little bit flexible. So what we'll do is we'll click on our wood object here, and we'll come down here to add metadata, and we will add our metadata. So we'll add a surface type metadata to this object and hit add. You will see down here we have a metadata surface type. So we can say this object is made of wood. We can do the same thing with our concrete. If we come over here, we added a metadata and we say surface type, we can say concrete. And there we go. Simple enough, right? And then we can pull back our surface type just by saying surface object dot get meta, and we can pull back our surface type like that. And this will return a string. It'll return this little concrete meta type. And what we'll do is we will set some code up to automatically set these guys up, is what I'm thinking. I'm not fully sure how we're going to do that just yet, but that's the hope. How can we get our stuff from our global audio manager? Well, first we need to make it global because we don't have access to it. If I just type audio manager, you'll see that nothing comes up, okay? So that means that we can't just fetch it. So we need to actually make a global reference to our audio manager. So first we can go to our project settings. We can head over to our auto load. We can click on this little file icon. We can double click on audio manager. Then we can click on this guy and come to the front of it and type global audio manager. And the reason why is because I've ran into some bugs where it doesn't like being called audio manager because the actual script's class name is audio manager. So I'm not sure if that's a bug or if that's just a new feature, but it's something that I ran into. So I'm going to call it global audio manager and we'll click close. And now I want to pull back that data. So we'll just say global audio manager dot sound dict, and we'll pass in this whole thing right here, and that will return back a surface. And you'll see result is not defined, so I'll paste a surface result in so that way it matches up with the rest of this. And this is going to pass back a surface, so we need to have some kind of variable to hold that. So if we come up here and we hit enter and we type var surface is a surface, and then we could just say surface is equal to our global audio manager get meta surface type. Now, you might be asking yourself, okay, Mitch, but what happens if our object doesn't have a meta type? Well, that's a good question. So we can check for that. We need to make sure that our stuff is safe and secure and not going to blow up on us, right? We don't want our project to crash on us when we're playing our game. So if we come up here, we could just type if surface object dot has meta surface type, then we're going to pass this guy in. Now that's really great, but we can't let this get past the rest of our code down here without having some kind of type or without having some kind of surface. Whether we know it's a type wood or if it's a type concrete, it doesn't really matter because we're going to get null references if we let it be null after this. So when we initialize our object, let's just set it as a concrete type like that. And that will allow us to pull back just a base sound. And we can come up with a bass sound that is not specific like concrete. We could just come up with a bass sound that exists. But in our case, since I don't have one, we'll just use concrete, but know that we will build one in the future. Now, we can guarantee that our sound exists, and we can guarantee that we actually have a non-specific way to get back our sound, which is great. So now we can just set up our sound playing. So we can scroll down here. So before we actually can play our sounds, we're going to need some kind of way to play our sound, right? So if we right click on our player, so make sure we click on our player here, and we right click, add in a child node, and let's add in an audio stream player. And since we're not doing any 3D audio, because this isn't something that the player's going to be hearing from a distance, they're going to be hearing it right from them. So we're not really worried about having distance-based audio. So we'll just grab the audio stream player. So we'll click that, hit create, and then let's name this footstep like that. And then we'll come in here and we'll hit enter. And we'll hit $footsteps.stream is equal to surface dot walk stream wave. And then we can play that. So $footsteps dot play, and that will play our sound. So now if we've done everything correctly, we should be able to hit play and we should be able to hear our stuff. So let me turn on audio for you guys real quick and make sure I have it at a reasonable volume. And let's hit play and let's see if all of our hard work is played off. Oh, and it looks like we have a crash, invalid, set index walk wave on base nil. That's because our surface is null. So we're going to need to set this to a new surface. So hit equals surface dot new like that. And we're going to need to do the same thing down here. So let's copy this. Let's hit paste. Let's control S and let's refresh this. All right. So it started up. So that's a good sign. So let's head over here. Awesome. So now it's actually playing our sound. Although it looks like it's playing the wrong sound for both of these guys. It's playing the exact same sound regardless, which is not quite what we're looking for. And we're also going to need to do some cleanup to make it so that it's not playing the entire sound if we stop. I don't know if you've noticed that, but if I walk over here, even if I stop, it plays the sound completely. And we don't want that, right? If you stop, the character is not going to keep walking. So we need to plan for that. Now, we do have our sound dictionary, footsteps on wood, footsteps on concrete. So that part is correct. And our sound dict wood and our sound dict concrete is also here. So let's take a look at our test scene. Let's go to 3D. Let's take a look at this guy. This says concrete. This guy's surface data says wood. So that's interesting. So let's go take a look at our code and let's see what it's doing. So if surface result is greater than 0, surface result has collider, then it's getting the meta. If not, it's choosing concrete. So my guess is it's probably not fetching back the object it's looking for. That's going to be my guess. So let's do a print here and let's print got surfaces. And then let's copy this, paste it, and let's say got a collider. And then let's see if that works. We do have a debugger. Let's see if our debugger has anything. It does not. So we'll hit play. We'll see what we get. Got surface, got collider. Got surface, got collider. So it's definitely doing what we expect. Did I spell surface type wrong? Sounds like something I would do. Let me check. No, that looks about right. I wonder, did it get back? Let's see. Well, it definitely doesn't have the meta type that we're looking for. So surface type. So the surface object is this object node 3D surface result collider. So let me do this. Let's hit play. Let's head over here. We'll throw a breakpoint here. And let's see, surface object. Let's take a look at this real quick. It is a CSG object. Its position is 0, 0, 0. So this is the wrong surface object. Do these guys not have collision? They don't. Okay, so that's why. So you can see here, these guys don't actually have collision. Let's turn on their collision. Let's see if that fixes our problem. So I will uncheck this guy, refresh this guy. And there you go. Awesome. So now that we're at this point, we just need to make it so that our character does not play the sound if he's not walking. So if we come down here, you can see that we're playing our footstep stream right here. But if we're not moving, then we shouldn't play that sound, right? So we're not moving here, right? So what we can do is we can just say if $footsteps dot is playing, then we can just say $footsteps dot stop. And that should fix it. So now if we head over here and we stop, you'll see it's not playing. So that doesn't quite work. You'll notice that there is no sound. See that? But if you let go, the sound gets played. The other one is if you tap it, it just plays it constantly. So that's kind of a problem. So the first question is, why is it that only when you let off does it play? Well, that's because it's actually playing it constantly every single frame. But since it's already playing, it just keeps overwriting your play. So basically think of it kind of like it's starting from the beginning every single time. So it's not playing the sound because it's constantly playing it. So we need to check for that. So we'll say if $footsteps dot is underscore playing, then we can play this guy, right? Except for we don't really want to do it when it's playing, so we want to say if not. And that should solve our problem with the sound issue. So if we come in here and we run, and there we go. Now the next one, if I hit W and I just tap it, that's kind of a problem, right? So we need to be able to stop the sound if we tap the button, right? Or if we let off of the button. So we can come into our else and we could just say if, and we can basically run footsteps is playing. Then we can say $footsteps dot stop. We want the lowercase s instead. So we can hit play. And there we go. Awesome. One other thing you'll notice that if I jump, it's still playing the sound. So we can fix that by coming in here and saying if footstep is playing and is on floor, then we can play this sound. And that'll solve that problem. So awesome. So now we're getting pretty far down here, aren't we? So now we're going to need to set up a thing for when we're crouching. Now we don't actually have a crouching sound. So what we'll need to do is we'll set up the logic and then I'll have to go and find a crouching sound and then we can set that up. But we can come in here and we can just say, hey, if we're playing and if we are on floor, then we can also check if we are crouching. Then if we are crouched, then we can just play our crouched sound. So $footsteps dot stream is equal to surface dot sneak wave stream dot wave. And then we can say else our footstep sound is the walk sound. So that'll basically allow us to say if we're crouched, then we can sneak. If not, then we'll walk. Now we don't actually have a sneak stream. So if we go back to our audio manager, I'm just going to basically duplicate this footsteps on wood. And I'm just going to set our sneak to that. And then we'll do the same thing with our concrete one. We'll just copy and paste that. And we'll put our sneak one as that as well. So next, we need to make it so we can jump and land. So it's going to be kind of complicated, but basically we need to detect when our character's in the air and kind of falling. So next, we're going to do our jump and land sounds here. And basically how we can handle it is we need to determine if our player has been in air. And if we go over to our character control, I can kind of show you guys. So we do have the ability to pull back if the character is on the floor. And that's, I believe we've used it a few times here, but we can't use that to actually determine if the player was in air on the last frame. Because when you do that check, you're actually checking it at that frame at that time. So you're really checking if the player is in the air currently or on the floor currently. So you need to create some kind of Boolean to handle that. So let's scroll up to the top and actually create a Boolean here. So we'll say var was in air. We'll make that a type Boolean. And then we'll scroll down to our move in slide. And what we're going to do is we're going to check if we were in the air or on the ground just after this move in slide. And the reason why is because we know after everything that's been done, we know if we are currently on the floor or if we are not. And then from there, we can make a good guesstimate of if we've been in the air. So what we'll do is we'll say if is on floor, then we can just say was in air is equal to false, because we know that they weren't in the air because they were on the floor, right? And then we can just say else was in air is equal to true. Now, if you want to make this fancy, if you really want to make this super duper fancy, you could just say was in air is equal to not is on floor. And that technically is the exact same code here, but just more compact. And one of the things that I always like to tell you guys is, compact code is always a good thing. So, just keep that in mind. So now that we have whether or not we were in air, right, our last frame, let's come up here and let's get our sound to actually work. Now, if we head up to where we're doing our jump code, which is located right here, first we're saying, hey, if you press the button and you are on the floor, then you can jump. But we don't necessarily want to do that, right? We want to say, hey, if you are on the floor and you were in the air in the last frame, then play your sound, right? Because you've officially landed, right? We know you're on the floor. You were in the air last frame, so we know that you've landed, right? The eagle has landed. We're good to go, right? And we could play our sound. But we don't really want to have this if UI accept here, right? So what we can do is we can kind of hijack this is on floor check here and do some additional logic here just to make things a little bit easier on us. So what we'll do, so come in here and say if is on floor, like that. We can get rid of this and statement. And then we can say if you were on the floor and then if you press this action, then we're good. We can go ahead and jump. And then we can also check if was in air, then we can play our sound. Because now we know that we were in the floor, we were in the air, and we are now currently on the floor, right? So we can just grab our audio stream and play it. Now we could pull back our footsteps and we could just run that. But the problem with doing that is if we just say, hey, $footsteps.audio stream is equal to our jump sound and then play our sound, when we come down here, our footsteps is not going to play. And we also, if we let off of our W, then our jump is going to stop playing. That sound is not actually going to happen. And that's a pretty big problem. So instead, what we can do is we can go to our character, we can grab our footsteps, we can copy it, pull it up, right-click it, rename it, and rename it to jump. And then we can head back over here and we can scroll up to where our if was in air, and we can just say $jump dot stream is equal to surface dot jump and land stream wave. And then we can just play it. So $jump dot play. And there we go. Now, if everything's been done correctly, we should be good to go. We can just hit play, and hopefully, if my sound is on, let me check. It is not, so I will turn it on for you guys. If I come over to my project and we jump, it doesn't seem like it's working, which is not a good sign. So let me put a breakpoint here. Okay, so that's not a good sign. So was in air is not being set properly. I wonder if maybe we need to put this above. Let's try that instead. Let's refresh this and let's see. Okay, so there we go. There we go. So if we do that. That's not bad. Now, the only thing that we're running into is if we jump and we're moving and our sound is still playing, we do run into an issue where it's still making that sound like we're walking. So we might want to say footsteps playing. If direction this and on floor, then we can also say if not is on floor, we can actually just tell this to $footsteps dot stop. And that'll probably help that. Now, one of the things that we definitely need to do, and we'll do this in our next frame, our next, yeah, that works. Yeah, I think that works. Now, the next big thing that we need to look at is how can we get our sound system to actually have it so our enemy can detect us? Because right now we're playing the sounds, right, which is cool. And we now have it so we can jump and make noise, but we need to be able to notify the enemy character that it can hear us. And how we can do that is we can create a noise value, right, for each of our surfaces. Now, if you look at our surfaces, we have sound value and land value, right? And we are playing our sounds here. So what we can do is if we're playing our sounds, we can just set a value on our character of what our sound value is. So if we scroll up to the top, we can add in a noise value. So we'll just say var noise value. We'll make that equal to 0 real quick. And then we'll come down here and wherever we're playing our sounds, so for instance, jump, we can say noise value is equal to surface dot sound land value. Then we can come down here and say if we are doing our sneak sound, then we're not going to play any sounds because we'll allow our character to have a noise value of 0. And if we are walking, we'll set our noise value to surface dot sound value. Now, something that we should check for is if our noise value is greater than the sound value we're setting it to, because if it is, we don't necessarily want to override that. So for instance, if jumping and landing is a louder sound, we want to make sure that that noise value takes precedence. So we can come up here and just say if noise value less than our surface.sound value, then we'll set our noise value. So that way, always the loudest value takes precedence. You always want to make sure of that because it just makes sense, right? Now, so instead of setting our noise value equal to 0 here because you're not moving, instead what we can do is we can come up here and just reset our value. So we can just come up here and just say noise value is equal to 0, and that'll basically handle our noise value, if that makes sense. And that way, our noise value is always 0 at the beginning of our process. And then if we are jumping or if we are moving, then our noise value will change. And now we can print our noise value. So we'll just type print noise value and we'll hit save. And now I'm going to go find a couple of my prints and I'm going to get rid of them because I don't want to pollute our print system. So I'll get rid of like this light value and I'll come down here and I'll get rid of our prints here that we have. So we'll get rid of these guys. Those aren't very useful anymore now that we know it works. So if we hit Control S and we move, all right, you can see we're at 0. We're still at 0. If we move, we're still at 0, so let's see if is it not on floor, play, this guy. if it's playing, or and on floor, if crouched, then do this. So what I'm thinking is going on, and we're going to need a state machine. We really, really need a state machine. So that'll be our next tutorial. But what we'll do is, for now at least, is we'll grab this guy and then we'll just paste it like this. That way it's playing our surface sound value, and then we can just check if we're crouched. So and not crouched. I don't like that, but I think that'll be the easiest way. I think that will work. So I think we'll be good. So if we hit this, there we go. You can see we have 5s, 10s, 5s. Yeah, I think that'll work. Okay. So I think that'll do it. So basically all we needed to do is just move this guy out, and we'll move all of this into a state machine, which will make this a lot easier to manage in our next video. So now we just need our enemy to listen for that. So if we come over to our enemy and we scroll down to where we're checking for our player, there is a section in here where we actually listen for our player. And I believe it's right here where we're doing if player is in earshot close, if player is in sight far. We can just check for our earshot. So we can say if player is in earshot close, and if result collider dot, and we know that our value is sound level, if I remember correctly, or noise value. Noise value is greater than, and we can now determine what kind of noise we're going to have. So in our case, we'll just say if it's greater than 1, we'll hunt after the player if they're in close range. Then we can do the same thing down here for earshot far. We can just say, okay, if you're in earshot far, then if our noise value is greater than 3, then we can hear you, right? So if I hit play, and he might be too far away, so let's go into our test scene and let's check that real quick. Because he actually seems like he's quite far away, so he's not going to be able to hear us anyway. So we'll just grab these two guys. We'll bring them closer. Like that. And then we'll hit play. And you can see he can now hear us. We definitely need a sneaking sound because that's way too loud. But you can see that it does seem to be working. Now, this is great, but we want our enemy to actually respect distance, if that makes sense. And what I mean by that is when you are really far away from the enemy, distance falls off over time. So we kind of want to create a gradient between us and the enemy. And what we can do is, instead of just checking our noise value, we can just pull back our noise value, and then we can divide it by our global position. And then we can get a distance to our player. So our result.collider right here dot global underscore position. And we can check if that's greater than a specific value. Now, this is going to be a 0 to 1 value, at least with any luck. It'll be a 0 to 1 value. And we'll just kind of grab this guy, copy it, and then come down to our noise value check right here. And we can select right here and paste that guy in like that. And then we should be good to go. So if we hit play, you'll see that he can't hear us. Now, we might want to print out what our noise value is, so that way we know what in the world we're trying to see. So let's grab these guys, and let's copy it, and then hit print our noise value. And then let's go back to our character, and let's shut off our print for our player. So if we hunt that down real quick right here, and we get rid of that guy, and then we refresh, and let's see how loud this actually is. So 0.36, 0.35, 0.36. 0.46. So you can see how it's kind of in a scale to 1. So that might work. Let me refresh this real quick. So if I jump, you'll see that we got a 7 in there. I think that will work. So So what we'll need to do is we'll need to set this up so it makes sense, right? So everything's from a 0 to 1 scale, except for sometimes you'll see a 1 in there. And obviously, since we're dividing it based off of distance, if the value is above like a 10, it's going to be a 1 point something, right? So think of it kind of like this. What we're doing is we're getting the distance of us to our enemy, and then we're dividing out the difference here. So you can set up some really interesting interactions based off of how loud a sound is versus how close you are versus how attentive the enemy is, if that makes sense. So we have a lot of options here to work with. Now, the first one that I want to look at is I want to put this at something like a, instead of 3, make it like a 0.8. And instead of a 1, if I'm really close to you, right? Because this is a player in earshot close, we can set this as something like a 0.3. I think that'll be fair. So now it should. There we go. And you can see now he's hunting after the player. And if I walk over here, now he's hunting after me even more. See that? And now he sees me. So now he's chasing after me. There we go. And I think that'll work. Well, see, now he's chasing me because I'm bad at my own game, but I think that that'll work. Now, his waiting state, he's not actually checking for the player. That's something that I've noticed, is that when he's in waiting state, he doesn't check for us. So we need to fix that. That's definitely a problem. So what we can do is when we're in our waiting state, we'll just check for player up here. And there we go. And that'll help with handling our check for our player to see if our player is near us. And that way, even when he's, there we go. And you can see he heard us and he moved into our area. And now he's hunting after me because I got too close and I made too much noise. I mean, he is very attentive, but I think that that will work. And now the nice thing about all of this is that we can just basically tune these values to whatever we want. Now, something that we probably should do is we probably should set these values up here instead of just 0.8 point something. So we'll set that real quick. So we'll just say var close light level is equal to, and I believe what we had for our light level was 0.3. And for far, it was 0.6. So we'll say 0.3. And then when they're far, we'll do 0.6. And then when they're far crouched, we'll do point, I believe it was 0.7. And then we'll do the same thing for our sounds. So we'll have close sound level. And far detection level as well. And we may want to say far light detection level and far crouched detection level, close light detection level. And then we can just kind of come down here and edit these guys real quick. And this tutorial's kind of devolved into me doing a little bit of refactoring, but that's okay. We'll just grab that guy and then we'll say this one is far light detection level and then far crouched light detection level. And then here we'll say far sound detection level and then close sound detection level. And that'll just help us out. And we can also export these guys out so that way we can have a little bit of a easier time messing with it. We'll just grab this guy and paste, 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 and paste. And there we go. And that'll be a pretty good way to set our stuff up so that way we actually have a decent detection system that is flexible and we can change it right here instead of needing to change it in code. Now, I think at this point we're pretty much good. We've been doing this for at least a half an hour, probably an hour at this point, maybe longer. And I think we're good to go. Now, one of the things that we're going to need to do in the next video is we're going to need to change our entire character script over to a state machine. It's getting really messy and very, very dirty, and we need to do a giant refactoring episode. And as I know people hate refactoring episodes, but it really needs to be done. And of course, the code for anything is always down in the description below. So, you guys don't even have to pay attention to the refactoring episode. That's totally fine. We'll be talking a lot about design and about code architecture, so you might want to be there. So check it out next week. Hopefully it'll be out. But that is all I have for you guys today. So thank you so much again for watching, and I'll see you all next time. Thanks.